Okay, here's a technique that's cropped up in a couple of papers. There was a 2018 question like it as well. And here it is on 2020 paper 1, question 7. And actually, I'm not going to talk about the inequality part of this question. It's just about the fact we need to find, for this question, the equation of the parabola, the curve. We're told it's a quadratic, and we're told that this is its minimum value and that it crosses the y-axis at 25. So it might be tempting to say, okay, so it's going to be y equals x squared plus some x's plus 25, because I know that when x is 0, it's going to cross at 25. But the trouble with that is that we can't assume it's just 1x squared. It might be 2x squared, it might be 3x squared, it might be 4x squared, it could be anything. So I think it's probably easiest in this case to say, right, let's write it in completed square form. There might be a number of x squared. So let's say it's a lots of, well, if I know where the turning point is, I know that if its x value is -2, there's going to be a +2 in the bracket, and that's going to be the same as that, so that's +13. And I, as well as knowing it goes through 2, 13, I also know it goes through 0, 25. So if I make x 0 and y equal to 25, 0 plus 2 squared, so that's 4. So that tells me that it has 3x squareds. So it's going to be 3 lots of x squared plus 2 plus 13. So my suggestion is, if you are told about a quadratic and you know the turning point, you write it in completed square form. Don't assume that it's just a single x squared though. So we need to say, right, we've got some x squareds, I called it a, and then I worked out what a was using other point that were given. I don't think that approach is as good. Hopefully that's okay. Remember, having a multiplier in front of the bracket there makes no change to the turning point. It doesn't change the location of the turning point at all. Okay, that's that question.